Okay, ratio test, right? Quick rundown. It's the limit of the nth plus 1 term divided by the original series, right? And that's going to equal some number. If the number is less than 1, we have absolute convergence, greater than 1, divergence. If it equals 1, the test is inconclusive. Okay, so all it means is we're going to plug an n plus 1 in for every n in the original series, and we're going to multiply it by the reciprocal of the original series to see what happens. Take the absolute value, of course. So nice and simple, 10 to the n over n factorial, and that's when you want to use ratio, by the way, is when you have factorials. That really is helpful. So we've got our limit here. I plugged in an n plus 1, plugged in an n plus 1 here, right? And remember that we're trying to force it. We're forcing it to be less than 1. It doesn't mean it's going to happen, right? But we're trying. So what you're showing the grader is, I want this thing to converge. We're going to see whether it does or not. Anyway, using rules of exponents, we can simplify it a little bit more like that, so we can cancel those n factorials and those 10 to the n. So what we're left is with the limit of 10 over n plus 1. And by the way, at this point here, I can say I applied the absolute value and put this in parentheses if I want to, because there's nothing negative in there. When I take the limit, right, I have 10 over infinity, which is 0. That's less than 1. So I can say that the original series converges by the ratio test. There's another one. We have 3 to the n over n squared. So again, I plug in an n plus 1, and for every n that I see in the original, multiply it by the reciprocal of the original, try to force it to be less than 1. Use rules of exponents to break this up so I can cancel some stuff out. And what I see is that I can cancel the 3 to the n's, and that's it. So I'm left with 3n squared over n plus 1 squared. Now, the degrees are the same, n squared here and n plus 1 quantity squared is going to give me an n squared in the bottom. So the limit of that thing is 3. That's bigger than 1. So I would say that my series diverges by the ratio test. And here's one more little weird one, or quirky one. It's no big deal. Okay, so here's the quirky little one, and it's not hard, it's just we have a number here raised to the n. So if I'm going to use the ratio test, I'm going to plug an n plus 1 in for every n that I see. I did that. Multiply by the reciprocal, force it, or try to force it to be less than 1. Cleaning this thing up, this is not going to change. That's not going to change. But down here, I'm going to have ln3 times ln3 to the n, so I did that. And that cancels with that. And so I'm left with this little mess right here. But guess what? If I cube this, or if I expand this out, I'm going to have n cubed, right? And down here I have n cubed. So this is just, the limit of this thing is just the ratio of leading coefficients. So it would be 1 over ln cubed, ln3, that's less than 1. And so I can say that A sub n converges by the ratio test.